Good day to you all, grade 11 and grade 12. My name is Messiah Ndo. In this tutorial, I'd like to take you through general solution in detail, and I can advise you guys, boys and girls, be with me until the end of this session, since we're going to enjoy in detail here this trigonometry here. If you do have some problems based on physical science and mathematics, don't hesitate, just hit me on my email, messiahndo95@gmail.com, or you can also WhatsApp 071 or 071 576 8614. All right. Just allow me to take you through the concept quickly. As you can see on my left-hand side, I have got the Cartesian plane here, and I hopefully is not for the first time seeing this, some of you. On my right-hand side, I also have got some few notes based on this general solution. This is what you have to know before you solve any kind of question based on the general solution. Just allow me to take you through the notes on my right-hand side here. Solving the general solution. Since you still remember that the period of the tan, it is 180, and the period of the sine and cos, it is 360, meaning that here when we solve the general solution, we're still going to stick on those points. Solving the general solution for the tan, we always add 180 degrees .k(z) in order for us to get the general solution. Then for sine and cos, we always add 360 degrees .k(z) for finding the general solution. But what is it that we must have on the table before we solve the general solution? We must have the reference angle, the RA on my Cartesian plane, down the on my left-hand side actually. You can see the Cartesian plane having the RA, denoted RA in terms of RA there. So you must have all those things before you solve the general solution. You must have what we call the reference angle. So if you are given an equation as an example, you have to solve the reference angle first. Then after that, you find the general solution. I hope you might be asking yourself maybe what is it that must be added to 180? What must be added to 360 for me to get the general solution? In fact, the part that it must be added, or the value that must be added to the general solution, it is the reference angle, the RA. So I'm going to show you how to solve the reference angle, and after that, solving the general solution as well. So just allow me to take you through an example so you can see in detail how to use this Cartesian plane together with the information on my right hand side. Try to have a look here in this example. We are given the sine of x equal to 2 cos of x. We can take this one as an example. Okay, they want us to find the general solution for this equation. What we have to do first is to solve this in order to get the reference angle. After getting the reference angle, then it will lead us to general solution based on the trig ratio that would be dealing with that particular situation. If we're dealing with the sine, dealing with the cos, we always add our reference angle to 360.k(z) for general solution. Depending on the Cartesian plane here, you will see for tan you always add 180 degrees .k(z) for general solution. Also depending, or it is depend where actually the tan is positive or negative in this Cartesian plane. Also, we are directed by equation or by question here. So try to have a look here on this question. They want us to solve the general solution for the sine x equals to 2 cos of x. Just because the angles are the same in both sides here, we don't have to waste time. The main point is to reduce these and find the reference angle for this. So what I'm going to do here, because I'm having the same angles in both sides here, I'm going to divide by cos of x both sides. Cos of x both sides, 2 to get the tan of x here. That's why I'm dividing both sides by cos. So what I'm going to do precisely is to cancel out this cos on my right hand side. I'm left with 2 here. Sine x divided by cos of x. You know, when you deal with the identity, this is the same as the tan of x. So how do we find the reference angle when you are having an equation like this? What we're going to do, we are going to apply what we call the arctan. The arctan of these two is going to give us our reference angle. So therefore, we're going to find our RA. Our RA here is going to be the arctan of this. You're going to say the arctan of 2 degrees. Then the answer that you're going to get here, we called it is the reference angle. So the arctan of 2, you can see that it's giving me 63.43 here on my calculator. You can also try to do it that side. So after finding the reference angle, now we have to go and identify the quadrants where the tan is positive. Or you might be asking yourself, why not tan negative, choosing the tan as positive? It is because here in this equation here, our answer is in terms of positive here. So this positive sign indicates that we have to take the tan as positive. So we have to go and check. Oh, sorry, let me just drag this down so you can able to see. Let me try to focus my camera in detail here. Okay, so you have to go and identify the Cartesian plane where the tan is positive. Just because the number here it is positive, this positive representing that you have to select only the tan where positive there on the Cartesian plane. The tan it is positive on my first quadrant and the third quadrant here, as you can see. So you have to ask yourself, okay, if the tan is positive on the first quadrant and the third quadrant, what must I do? We have got RA on the first quadrant. We have got 180 degrees plus RA on the third quadrant. These two equations we're going to use to find the general solution. So after that, you're going to solve the general solution, meaning that you're going to have two solutions here, the one for the first quadrant and the one for the third quadrant. Starting with the one for the first quadrant, that you can see here, we only have the RA. So you write down the formula. Just because our equation is in terms of x, you're going to write that x, it is equals to our reference angle for the first quadrant here, which is going to be RA. Remember that for sine and cos, we always add 360.k, k is z for general solution. But for the tan, we always add 180 degrees .k, k is z for general solution. And hopefully here we're dealing with the tan of x. So meaning that for general solution, we're going to use this. What is it that must be added to this 180? Is these reference angles that we are having here based on the Cartesian planes here. So based now on the first Cartesian plane, or on the first quadrant. On the first quadrant, yes, we're going to say RA plus 180.k, k is z for our general solution now. So what is the actual size of the reference angle? The actual size for the reference angle, it is 63.43 degrees plus 180.k, k is z. Now this is the general solution from the first quadrant. So we have to go and solve the one for the third quadrant. Then we are done with this. Then you're going to write OR. Still, you're going to write x because we are dealing with the x. The equation is in terms of x there. You're going to write x, it is equals to, instead rather of writing RA the way it is, you have to take whatever you're seeing here on the third quadrant. On the third quadrant, you are not seeing only RA, you are seeing 180 degrees plus A. You have to take this and paste it here. You're going to write 180 plus RA plus 180 degrees dot K, K is Z, because the period of the tan, it is 180, or we always add 180 for general solution for tan. So now after that, you have to substitute now here the reference angle as 63.4 degrees plus 180 degrees dot K is it. You can get the actual size of this sum of 180 plus 63,43, which is going to give us 243.43 degrees plus 180 degrees dot K is it. This is another solution. So this is how, guys, we solve the general solution in detail. So sometimes they can give you questions involving the restriction, but at the moment, since we are still dealing with the level 1 question, just allow me to take you through this level 1 question so you master it in detail. So this is how we solve the general solution when you use this. Okay, just allow me to give you another question. Another question now here. Another question. Just hold on. Okay, just allow me to remove this part now, so can give you the next question. Okay, we can assume again that we are given the sine of 2x multiplied by cos of 10 degrees minus cos of 2x multiplied by sine of 10 degrees, which is equals to -1/2. They want us to find the general solution for this. So solving the general question, you have to think thoroughly when it comes to the trigonometry. You don't have to focus here on there might be the compound angle, there might be the double angle, there might be the identity on these solutions that we are actually focusing on. Then we can have a look now on this equation. In this equation, as you have a look now, we are given the sine 2x, cos of 10, cos of 2x, sine of 10 degrees. As you see that we're repeating the same angles here, which is going to give us the double angles, right? We have to go and check the double angles. Remember the double angles identity. It's for the sine is said sine of either alpha minus the beta. It is equals to sine of alpha multiplied by cos of beta. And then just because it's the sine, there's no sign change. It will remain as the cos of alpha dot sine of beta. This is the compound angle identity. So you have to know how to expand it. You have to know how to reverse it. So I want us to differentiate this equation and this compound angle that we have in here. Just because this one, it is expanded, we can compare this and this one. You can see that this is look familiar with the compound angle that we're having, whereas this is our alpha, this is our beta, this is our alpha, this is our beta. It is the same sine of alpha, cos of the beta, minus cos of alpha, sine of beta. It's just that now instead rather of using alpha and beta, they were using 2x. B for beta, they're using 10 degrees. Same applies here. So what we have to do when we convert back, this is going to be sine into alpha minus the beta. So this is exactly what we have to check. So meaning that when we solve this, we have to convert it back in terms of alpha minus the beta. Our alpha denoted as the 2x, the beta denoted as the 10x. So therefore, we're going to just say sine into 2x minus 10 degrees, which is equals to -1/2, just because it is representing the compound angle identity. Once you have done doing this, you're almost done. What you have to do is to find the reference angle. To find the reference angle, now you are going to apply the arcsine of negative 1/2 here. You have to get now the reference angle. To get my RA, I'm going to apply the sine of this one. But now here we're going to left with 2x minus 10 degrees equals to this arcsine of this. But you don't worry about it. So means that the reference range is going to be the arcsine of this, but the remaining is going to be just the 2x. So what you're going to do is this. 2x minus 10 degrees will remain like this. Then you get your reference angle as the arcsine of. So put it in mind that this negative, we don't substitute it here when we solve the general solution. It is only telling us where sine is negative on our Cartesian plane. We don't substitute negative sign here when we solve the general solution. So be careful on that. So what we're going to do now here, this is our reference angle. I'm having 2x minus 10 degrees equals to reference angle as just a 30 degrees. Okay, just 30 degrees, the way it is. Or if you feel like it is confusing you, we can do it in this way round, like what we did, same like what we did on the first question. You can just write the reference angle equals to just the sine in arcsine of 1/2. Don't put the negative angle since it's just telling you the quadrant. So now your reference angle is going to be 30 degrees. So now you have to go and identify the quadrant where the sign is negative. The quadrant where the sign is negative is going to be the fourth quadrant and the third quadrant. And as you can see here, we are having 360 degrees minus RA. On the third quadrant, we're having 180 degrees plus the RA. So now what I'm going to do is to solve the general solution now, because the reference angle already it is here. So you can start with any here. You can start with the one for the third quadrant. You can indicate now for the third quadrant. For the third quadrant, just because now I'm not dealing with the x, but I'm having 2x minus 10, I'm going to write 2x minus 10 degrees, which is equal to the reference angle. Unfortunately, the reference angle on the third quadrant is not going alone, but is having 180 plus RA. I'm going to write 180 degrees plus RA, just because this is the sign, always at 360. So I'm going to write 360 degrees dot K, K E Z. Once I've done doing that, keep on solving. 180 degrees plus. Now the reference angle is just the 30 degrees plus 360 degrees dot K, K E Z. So I have to keep solving it until I get the value of x here. So now we're going to add these 180 plus this, just going to give me 220 degrees plus 360 degrees dot K, K E Z. Okay, so then now, I'm getting this. I indicated already this. Just allow me to press the calculator here. So this 220 I involved the 10 here as well. So, okay, just allow me not to omit the steps. So it's going to be the 2x equals 280 degrees plus 30 degrees plus 10 degrees plus 360 degrees dot K, K E Z. So when you combine all of this, it is going to give me just 220 degrees plus 360 degrees dot K, K E Z. Keep on solving. We need the x equals to something here. You're going to divide both sides by 2, divide both sides by 2. When we take it further now, the value of x should be just 220 divided by 2, it will give us just 110 degrees plus 360 divided by 2 is going to give us 180 dot K, K E Z degrees. This is the first general solution from the third quadrant. So now we have to go and find the one for the fourth quadrant. Fourth quadrant, we're going to do the same. You're going to write the 2x minus 10 degrees, which is equals to 360 minus RA. You're going to write 360 degrees minus RA plus 360 degrees dot K. K is at, because still we are dealing with the sign always at 360 dot K. So where there is RA, you have to substitute now. 30 degrees you keep on solving until you get the value of x at the end, or your solutions at the end is 360 degrees minus 30 degrees plus 360 degrees dot K. K is set. Here you have got 2x minus 10 degrees. What you're going to do now here is, obviously, you have to take the 10 inside as well. 360 degrees minus 30 degrees plus 10 degrees, because it was negative. When we take it inside, it's going to be just positive. 360 degrees dot K. K is it. So when you combine everything here, 360 minus 30 plus 10, it will precisely give us just 340. 340 degrees plus 360 degrees dot K. K is set. Now we have to divide both sides by 2 to get the value of x here, or our solutions at the end. 340 divided by 2. Obviously, I'm going to get 780 degrees. 360 divided by 2, still 180 degrees dot K. K is set. Now, this is the general solution for this particular equation that you are seeing here, guys. There's nothing much here when it's come to this general solution. Just allow me to give you one more question. So you can practice after this. Okay, I'm removing this now. I'm removing this. Okay, lastly, example number 3, they want us to find the general solution for the sine 2x with minus 1 minus cos of 2x, which is equals to 0. As you can see here, this one is in terms of double angles. The sine of 2x, you know that we have got only one way of removing this, whereas this one we can use 3 ways of removing this. Okay. So we just have to solve it. We have to solve it like as what we were doing on the previous questions. Same applies here. We have to replace this by 2 sine of x dot cos of x. I hope you will agree with me here, just because this is representing the double angle. Then minus 1 minus. Here on the cos, I will remove it by 2 cos square of x minus 1, which is equals to 0. The reason why I'm selecting this 2 cos square x minus 1 rather, it is because I want this identity that, I need identity that actually gonna cancel out 1. So if this is 2 cos square of x, it will actually cancel out this one, because it's going to give me plus on this one. That's it. That's why I decided to select this. When I remove the brackets, now it's going to be 2 sine of x dot cos of x minus 1, negative 2 cos square of x. This and this is going to give me plus 1. Here indeed you can see that negative 1 plus 1 will cancel out, so that I'm going to left with 2 sine of x dot cos of x minus 2 cos square of x, which is equals to 0 now. So in this case, regards, you just have to take out the common factor. You see we have got common factor of 2 cos here. You take out the 2 cos of x out. We left with just sine of x, then minus cos of x, because we're having cos square of x here equals to 0. So solution number 1, we're going to have 2 cos of x equals to 0. or just sine of x minus cos of x equals to 0. Then when we solve it further, obviously we're going to divide both sides by 2. At the end, I'm going to get the cos of x equals to 0. This side going to take cos of x that other side. In order for me to get tan, I'll divide both sides by cos of x so that this and this cancel out. Give me 1 tan of x here. So what's left for me to do, I've got two different trigonometric functions ratio here. So that's the cos of x and the tan of x. So what I'm going to do, I have to focus under cos specifically and under the tan specifically. So I have to find the reference angle for cos now, which is just going to be the arc cos of 0, which is going to give me the reference angle for just 90 here degrees. Then now the reference angle now for this is going to be arc tan of 1, which is going to give me precisely 45 degrees here. So now we have to go and identify the quadrant. We can start with the general solution for the cos, because here we are solving cos and the tan at the same time. So we can solve the cos first, and thereafter we solve the one for the tan. So you have to identify the quadrant. That is positive. So you have to identify where the tan is positive, which is first and the fourth quadrant. So now, because we're dealing with just the x, you're going to write now x is cos your reference angle plus. Since it's still dealing with the cos, we have to add 360.k, because sine and the cos we always add 360.k. So you're going to add your reference angle here plus that 360 degrees dot k, k is for the first general solution for the first quadrant actually. So it's going to be x RA is 90 degrees plus 360 degrees dot k, k is So this would be the first general solution for cos using the first quadrant. Then now we have to go and get the one for a fourth quadrant. First quadrant we have got 360 minus RA. So I'm going to write 360 degrees minus RA plus 360 degrees dot k, k is Now what's needed now is to substitute the RA as 90 degrees plus 360 degrees dot k, k is Now we have to combine, or we have to get the actual size of this 360 minus 90. Hopefully it's going to give us 270 degrees plus 360 dot k, k is This is the general solution based on the cos. So since we are solving them all together, we're done with the one for the cos. Now we have to indicate for the tan. Tan, it is positive here. So you have to identify the quadrant where the tan is positive. Obviously, it's the first and the third. RA and 180. So just allow me to squeeze it here. The first one is going to be just RA plus. Just because now I am dealing with the tan, always add 180 degrees dot k ez for general solution for tan. So it's going to be 180 degrees dot k, k ez. X, the reference angle for the first one will remain as 45 degrees plus 180 degrees dot k, k ez. Or the one for this is the first quadrant, the one for the second quadrant, for the third quadrant, it's gonna be x is equals to 3, sorry, is the third quadrant, not the fourth. It's gonna be 180 degrees plus RA plus 180 dot k, k ez. We substitute now the RA as 45 degrees plus 180 degrees dot k, k is So we can able to combine 180 plus 45, which is going to give us 225 degrees plus 180 degrees dot k, k is This is how we solve the general solution, done without a restriction. So on the next question, on the next lesson, guys, I'll be showing you how to solve the general solution involving the restriction to find some other values maybe that are between, as an example, negative 180 to 360, depending on the question, right? For now, I would like guys to take it bit by bit. I want you to familiarize yourself with the level 1 question. There it is. Here it is. Here it is. Here it is, guys. Here it is, guys. Just enjoy. Just enjoy. Just enjoy the general solution. Then here, if you are blessed, if you enjoyed my presentation, guys, don't forget to subscribe. Don't forget to subscribe. We will meet once again on the next session. Bye bye. Goodbye.